This video is going to be about the spectral classes of stars. In the previous video, we talked about how a star can be considered a black body, and therefore its spectrum differs based on its temperature, according to Wien's law. And we can determine the temperature of distant stars, even though we can't physically measure them directly, by looking at their peak wavelength emitted. The spectra of stars follows the classification OBAFGKM, and it goes from bluer stars to redder stars. If you have trouble, you should know this classification from hottest to coolest, and to do this you can use the acronym OBA Fine Gorilla Kiss Me. O-class stars, because they are the hottest stars, are also the most luminous, and M-class stars, which are the reddest star, are the least luminous class, because they are the coolest. One way the spectral classification of the stars is used is on a Herzberg-Russell diagram, or HR diagram for short. You can see the spectral types across the top here, O, B, A, F, G, K, M, from hottest on the left to coolest on the right. And on the y-axis, luminosity is plotted, and temperature is plotted on the x-axis, with the hottest temperatures being on the left and the coolest temperatures being on the right. You'll also see on this diagram these circles with dots next to the R. Those indicate the radius relative to our sun's radius. So anytime you see a circle with a dot, that means it's relative to the mass or the radius or whatever of our own sun. So with the way this diagram's set up, the hottest, most luminous objects, or stars, are in the upper left-hand corner of the HR diagram, and the least luminous and the coolest end up on the lower right-hand corner of our HR diagram. Notice that the majority of the stars plotted on the HR diagram fall in this line from the upper left-hand corner to the lower right-hand corner. We call the stars on this line main sequence stars. Stars in the main sequence follow the trend that cooler stars are less luminous and hotter stars are more luminous. Most stars are main sequence stars, and main sequence stars make up about 90% of the stars we can see. Stars of the main sequence use hydrogen for fuel, and if a star is on the main sequence, its mass luminosity has a very specific relationship. The luminosity is proportional to mass to the 3.5, meaning that a small increase in mass will lead to a large increase in luminosity, and that the most massive main sequence stars are also the most luminous. Stars that are not on the main sequence are stars that do not use hydrogen as their fuel source. The first type of group of stars we'll look at are red giants, which are found in the upper right-hand corner of the HR diagram. We can see from its position on the HR diagram that red giants are actually cooler than stars like our sun. However, we can also see, because they're in the upper right-hand corner, they're cool, but they're also very luminous. And this is because they have a very large size, i.e., they're giants. Red supergiants are similar to red giants, but bigger and more luminous. Red supergiants are the same temperature or hotter than our sun. Supergiants are rare stars and only make up 1% of all the stars we observe. Supergiants are more luminous, so they'd be higher than red giants on the HR diagram, and they're warmer, about the temperature of our sun. So if I look straight up from our sun, red supergiants would be about here. As I traverse the top of our HR diagram, this is where all the other supergiants would be found. Toward the left-hand side, I'd have blue supergiants, and toward the right-hand side, I'd have red supergiants. Okay. The last kind of star we're going to talk about on an HR diagram is a white dwarf. So once a star has exhausted all its hydrogen fuel, it cools down, and what's left is a white dwarf. White dwarfs have a really low luminosity, but they have a very high temperature, so we know that they must be small. We can find white dwarfs in the middle to the left-hand side of our HR diagram. See how they are hot and they are not very luminous. Alright, that's the end.